So we're still doing Unit 2 review, and now we're looking at the practice test. Our first question gives us two functions and wants the simplified formula for q at p of x, which means we're going to put p of x into the q function. Right. So I'm going to, in order to get q of p of x, I'm going to take 8 and subtract 3 times 7 minus x squared. Now I need to be real careful here. A lot of people want to just subtract the 8 minus 3. We can't do that. Order of operations says exponent first. We have to square this binomial. Then we have to multiply everything by -3 before we add that 8. So let's start doing some of our simplifying. 8 minus 3 times 7 minus x times 7 minus x. All right? I am now going to go ahead and do this part right here. 8 minus 3 times 7 is 49. Outers is -7 and inners is -7, which gives me -14x. And a negative x times a negative x is a plus x squared. Right, next, I'm going to go ahead and distribute a -3 to each one of these, and I get 8 minus 3 times 49 is 147. -3 times -14 gives me positive 42x, and then -3x squared. Right, now the only thing I have left to do is put it in descending order, as well as get these two terms together. So the 8 minus the 147 is going to leave me with -139. So my final answer is 3x squared plus 42x minus 139. All right. Number 2, I don't know how the question mark ended up down there. It's supposed to be here. H at g of 18. So we got to first put 18 into the g function. So g of 18 is 4 times 18 minus 9. Put that in my calculator, and I get 63. Now I'm going to put that into the h function. So h at 63 is going to be 5 times 63 squared plus 8 times 63 minus 12. I would practice putting that in your calculator and make sure you get the answer of 20,337. Number 3, suppose the transformation x, y plus 6 and the scale change x divided by 3y are applied to the graph of y equals the square root of x minus 8. Write the equation that corresponds to the image. All right? According to this, I'm not going to add anything to the x, but x is being divided by 3. But that's in the rule, which means in the equation, x is being multiplied by 3. So I'm going to have x multiplied by 3 because these should be the opposite. As far as y, it says I should add 6. Well, if I add 6 right here, I'm left with minus 2. And I don't need to multiply y by anything, so that's my final answer. Number 4. Suppose we have this transformation applied to the graph of y equals 2 divided by 2x minus 5, where the equations of the asymptotes, this is like the other problem we had, of the image. Well, we need to first think about what are the asymptotes here. My asymptotes that I start with are, let's see, 2x minus 5 cannot equal 0. You cannot divide by 0. So 2x cannot equal 5. X can't equal, 5 divided by 2 is 2.5. So since x can't equal 2.5, x equals 2.5 is an asymptote. And if you can't have a 0 here in the denominator, this 2 divided by is never going to become 0, which means y will never be 0. So since y will never be 0, we have to have an asymptote of y equals 0. So these are my original asymptotes right here. Then I'm going to apply this rule, x minus 4, y minus 3, and I'm going to get my new asymptotes. I'm going to use the 2.5 right here for x, so 2.5 minus 4 is x equals negative 1.5. 0 minus 3 is y equals negative 3. All right, number 5. Let the square root of x plus 4 and h of x equals x squared plus 7. What is the domain of h composed with f? So we're going to put f into the h function. So we're going to have the square root of x plus 4 squared plus 7. Now, I realize that when you square a square root, the square root goes away. However, because the x plus 4 is underneath the radical to begin with, we have to make sure that x plus 4 is never less than 0, because then it will be negative. If x plus 4 is negative, then you can't take the square root of a negative. So x plus 4 has to, it can't be less than 0, therefore it must be greater than or equal to 0. I'm thinking asymptotes. Okay, x plus 4 has got to be greater than or equal to 0. It has to either be positive or 0. Subtract 4 from both sides. X must be greater than or equal to negative 4. Number 6, draw a graph that is reflection symmetric over the y-axis. Let's see, I could draw a quadratic. I could draw an absolute value. I could draw an inverse square. Draw a graph that is rotation symmetric around the point 2, 2. Okay. Go to the point 2, 2. I'm going to put a dot there. I'm going to put asymptotes. And then I will draw my curves like that. Right? Draw a graph that has no symmetry. Okay, I can draw a square root graph. Draw a graph that's rotation symmetric around the origin. An inverse graph. I have my cubed graph. Or I have my linear graph. Next, on the test, this will be a BCR. Draw a picture of a graph that is even. Okay, a graph that is even is reflection symmetric over the y-axis. I don't have to draw that one, but just make sure yours is reflection symmetric over the y-axis. An odd graph is rotation symmetric. I'm going to draw that inverse graph again. One that is neither even or odd, I'm going to draw the square root graph. Right. Consider the equation and prove that the function is odd. Okay, the odd test is f at negative x equals negative f of x. I've got to show each side. So let's see, f at negative x would be 4 times negative x cubed. minus 5 times negative x. And so I get 4 times, when I cube a negative, it just becomes negative x cubed. And a negative times a negative becomes a positive. And so I get negative 4x cubed plus 5x. Okay, let's do negative f of x. Negative 4x cubed minus 5x. Distribute that negative. And I get negative 4x cubed plus 5x. And therefore, it is odd because they're equal. Odd. Because f at negative x equals negative f of x. This is now the third time we've done a question like this. The graph contains the point negative 5, 9. What other point must be on the graph if it is an even function? Even, remember, reflects over the y-axis, so the only thing that changes is x. So negative 5, 9 becomes 5, 9. If it's odd, then we rotate and everything changes, x and y. So negative 5, 9 becomes positive 5, negative 9, sorry. Okay. And what point must be on the graph of the inverse? Because remember, this means inverse. So that's when xy switches and becomes yx. So negative 5, 9 switches to 9, negative 5. What translation maps the graph y equals 4 over x onto the graph 4 over x minus 7 plus 8? That's going to be the translation where I'm going to add 7 because the rule and the equation should be the opposite because x lies in the equation, and y plus 8. Right, number 9. The graph of an equation has an x-intercept of 5, 0. So I start off with 5, 0. What is the new x-intercept under this transformation? Okay, I'm going to put 5 in for x. 6 times 5 is 30, plus 7 is 37. 4 times 0 is just still 0, so 37 is the new x-intercept, x-intercept. Write a scale change that has the effect of shrinking horizontally, that's x, by a factor of a fourth, so 1/4 x. Compressing vertically, that's y, by a factor of a half. And remember, the rule never lies, so you could write it like this, or you could write it like that, either way. And this would be a scale change. Right, number 11, what is the equation for the image of the function below? All right, so if I started here and I went 2 to the right and 5 down, so I moved 2 to the right, my translation was x plus 2, y minus 5, but I want the equation. So, and my parent function, by the way, is y equals x squared. So it's going to be y equals x minus 2 squared minus 5. And number 12, if you apply the scale change to this graph, what's the equation? Remember, x lies, so x divided by 6 is going to become 6 times x. And y is divided by 3, I could put a 1/3 in front. Or I could have just said the square root of 6x divided by 3, like that. Either one would work.